Okay, so let me start over. So let's get started. So let me check. My voice is reaching to the Zoom. Okay, can you guys hear me? Yeah, I think so. Okay. So this is what we are going to do today. But before we start, there are a few announcements. So one is that the answers to the last week's assignment, PL01 basics, are out. So you can get it through the Jupyter interface, just like another assignment. So the name is ANS PL01 basics. So it will look like this. So after fetching it. So you should be able to see this ANS PL01 basics in the released assignment section. So just like the assignment, just press the fetch button to get the access to it. So this is one thing. The other thing is, so I have made available lecture recordings as well as some commentary videos explaining PL01 basics. So this is what I generally like to do. So rather than spending too much time on talking and explaining, okay, this is how Go language looks like, and this is how Julia language looks like. These things hopefully are explained mainly in the commentary videos, because not necessarily everybody's working on every language. So just go ITCLMS and get the playlist URL. So the subsequent lecture recordings will also be available from the same URL. So just see this section of ITCLMS, and you get a playlist that looks like this. So this is the recording of the last week. And these are commentaries to the last week's assignment. Oops, I forgot to start screen sharing. Okay, so as we are moving to mainly in-person lecture, I tend to forget these things. So sorry about this, remote folks. Okay. I'm not sure whether I should start over again, but yeah, hopefully you're okay with it. So I was just explaining these two announcements, and one most importantly, the lecture recordings and commentary videos. So these are available now. Okay. So did anyone tell me through the chat? No, nobody told me. So please, remote folks. So if I'm doing something terribly wrong, so just let me know as soon as possible. Yeah, these things happen all the time in the hybrid lecture. So I sometimes forget to take care of screen in the classroom, and I forget to start screen sharing on Zoom. So everything can happen. So. Okay. So I guess that's it for the announcements before getting into today's topic. So this is what we are going to do today. So the topic is basically about object-oriented programming. So all of these four languages, so they are not necessarily called object-oriented programming language, but this is mainly because it's already so common that virtually all new programming languages support object-oriented features in one way or another. So the exact way they support object-oriented programming differ from one language to another, but the concept is so common. So I spent 10 to 15 minutes, hopefully quickly, to go over what is the concept I'd like you guys to learn for today through the exercise. But again, the main thing is not my talk. The main thing is you're working. So this week you will be working on this PL02 OOP basics notebook. Just note that some of the link to the link in the last program 6 is broken. So just ignore it and go to one of these links. But this is a small thing. So you are going to spend 30 minutes or so doing this exercise by yourself. And after something like 11:15, you're going to start sharing your answers with others by writing your answers to the spreadsheet, just like the last week. But you still continue working on this notebook for another 15 minutes or so. But if you struggle, don't spend too much time scratching your head and trying to make it perfect only by yourself. Just consult the spreadsheet to know what others are doing. And after another 15 minutes and sometime around 11:30, let's summarize and exchange what you have learned in these pages. So this is a form in which you can share your thoughts with others. So this time, what you're going to share with others is not a particular code fragment. So it's more like just a natural language. So your thought, what do you think you have learned somewhat more conceptually? So this is what the form will look like. So for example, when you choose the Go language, you are asked first to imagine you are explaining Go language to someone who doesn't know it. And for someone who doesn't know the Go language, explain how to define multiple methods or functions of the same name, and how a method call determines which method gets called. Or the other question was how to declare the type of a variable that may hold values of different types at runtime. So this is the process of sort of conceptualizing or internalizing what you have learned through the exercises. So, but exercises is all about writing code, right? So you can do it without actually understanding what conceptually it is, right? So this last step is sort of important. You express or articulate in your own language what you have learned. Okay, so let's do it in the last 30 or 40 minutes of this today's class. Okay, so the conceptually it is all about this thing, object-oriented programming. So let me get started. How to do it in presentation mode? Yes. Okay. So what is object-oriented programming? So in terms of what you have in the language, so you first of all have something called a class. And well, I assume that many of you are actually familiar with this thing, at least superficially, when you have any experiences, for example, in Python programming. But just for the sake of explanation for someone who have no experiences. So a class is essentially a data type definition plus functions or something called methods associated with it. So a data type definition basically defines what data that belongs to this type or class look like, and their functions associated with it. So functions operating on data of that type or class. And well, there's another terminology called an object. So object is actually just a data instance that is created from class definition or type definition. So if you are familiar with, for example, C language, this is a relationship between the struct and variable of that struct. So this is not, so for someone who are already familiar with Python, this is what the class definition in Python looks like, right? So never mind if you do not know Python, but well, just to give you an idea. So the class definition often begins with the keyword class, but some languages use different keywords like struct. And class is typically followed by a class name. So in this case, you are defining a class called rectangular. And basically, a class definition determines what the data of that type or the class looks like. And in this particular case, each object of this class will have 4 fields: X, Y, width, and height. So essentially, an instance or an object of this rect class is encapsulating these 4 variables. So presumably location and size of the rectangular, right? And in the case of Python, this is how you create a data instance or an object of a class. You just call a function of the same name with the class name. And you are passing 4 values corresponding to these X, Y, width, and height, or whatever this special name method init takes. Right, so this is a class and objects. And more important is methods. So methods are essentially functions. But what is the difference between ordinary functions and a method, specifically called methods? Something specifically called methods. So methods are somewhat unlike ordinary functions in the sense that a method of the same name can be defined multiple times, so for multiple classes. So when you have, for example, class rect and class ellipse, both can have the method named area. Right? So area is meant to be a method that determines the area. So how wide is it? And of course, you know that how you compute the area of a rectangle, right? So just the width multiplied by height. And you also know how to compute the area of ellipse. So it is pi. Okay, so sorry, this is slightly. Well, so I didn't show the definition of ellipse, but okay, so radius along the x-axis and the other radius along the y-axis. So this should be good, but you get the idea. All right, so the point here is these are same area methods whose purpose are exactly the same, right? But what you do to compute the area is different depending on whether it is a rectangle or ellipse, right? So if you do not have anything like a method, you have to define 2 functions, one for rectangle and the other for ellipse with different names, right? So for example, in ordinary programming language, such as C, right? But in object-oriented programming language, if the class is different, you can have a method of the same name with different implementations. So this is probably the single most important concept in object-oriented programming. But you can not only define a single method name with multiple implementations. You can also call appropriate one depending on what kind of objects are you operating on. So this is a piece of code in Python that scans a list of shapes. And for each object in this list of shapes, you call this area method we have just defined, right? So you can imagine what actually happens if this list of shapes has both rectangles and ellipses. Well, it's pretty intuitive, right? So you don't have to check if this S happens to be rectangular or ellipse. You just call area. And an appropriate method will get called depending on whether S happens to be a rectangular or ellipse. This is the benefit of being able to define a method of the same name with different implementations, depending on the exact type of objects, right? So this is probably the single most important concept in object-oriented programming. So how the language determines exactly which method gets called? Well, this is pretty typically very intuitive and nothing nothing mysterious happens. So in the case of Python, so if S happens to be a class, so if S happens to be an object of class S, then area method defined for class S will get called. The basic rule is as simple as this. But different languages have slightly different mechanisms for it. So you will learn of what it will look like in the particular language you chose. So there's some interesting and important language design points. So the first, somewhat superficial issue in language design when you want to do something like this. So when the language want to allow you to do something like this is, so how you declare a variable of S or shapes when S may take a value of different classes over time at runtime, right? So when you run this loop in Python, whereas S gets assigned different instances, different elements of this list, right? And one time it may be rectangular, and at another time it may be ellipse. So S may take a value of different classes or different types over time, right? So the one design issue, the language design issue is, so if the language requires you to declare type of each variable or type of some variables, so how to declare or specify the type of something like S or shapes, right? So you cannot simply say this is this S is rectangular or this S is ellipse, right? So it may be rectangular or ellipse, right? So how you exactly say something like this? So this is one language design issue. But some languages actually do not require type declarations at all. So at least superficially, this is not an issue for languages that do not require type declarations. But for languages that require type declarations, so how is an issue, right? But actually, there's a more fundamental issue. So whether you explicitly write type declaration or not, it's somewhat superficial issue. So the more fundamental issue is that how you guarantee before execution, prior to execution, that type errors do not happen at runtime. This is actually a more fundamental issue. So type errors, so by type errors, I vaguely mean that at runtime, the program is trying to apply a non-existing method on any data. So in this particular case, if a value assigned to S does not have an area method, so runtime type error happens, right? So this is what I vaguely call type errors at runtime. So how you guarantee that these types of errors do not happen at runtime? So this is actually the more fundamental safety issue of programming language. And such property is generally called type safety. And some programming languages employ an algorithm that checks type safety prior to execution. And such an algorithm is often called static type checking. So the one thing that I want you guys to think about through the exercise is, do these languages, that the language you chose, guarantee type safety? Is it trying to guarantee type safety at all? Or is it somehow completely forgot about it? So here are some different approaches to this type safety and static type checking. So some languages completely forgot static type checking and therefore type safety. So those languages simply accept that type errors do happen at runtime. Well, this is what you generally witness all the time when you program in Python, right? So after you think you finished writing your code, you run it, and most of the time, well, some runtime errors happens, and often it's some method. So you are trying to call some method on object that do not have that method, right? So this happens all the time when you program in these languages. So not just Python, but many of the so-called scripting languages, the JavaScript, and some earlier languages like Lisp or Smalltalk. The other extreme is to completely disallow something called a polymorphism. Polymorphism is just like I said, the property that a single variable or a single expression may take values of different types over time. So disallow polymorphism altogether. So when a variable is of type S, it is always having a value of type S at runtime. So this kind of program cannot be written in this approach. So there's an ancient language such as Pascal that takes this approach. So with this approach, it is relatively trivial to make it type safe. But it is relatively easy to guarantee that type errors do not happen at runtime. But this is sort of a very restrictive and lacks generality and flexibility. So some languages do some loose static type checking, but allow polymorphism via unsafe cast between pointers. So this is the approach taken by C or C++. So I do not get into this, but so if you think about how, for example, C allows a single sorting method to sort an array of any type. So that the same function can be applied to an array of, for example, rectangular and an array of ellipses. You can do it only through unsafe casts between pointers. So this is not a satisfactory answer, actually. And was satisfactory answer that you are going to learn in this course is approaches in which it allows polymorphism, yet guarantees type safety via this notion of subtypes. So what is a subtype? So subtype relation it is a relationship between two types. So let's call them C and P. I use C to stand for child type, and P stands for parent type. We say C is a subtype of P and write C less than or equal to P if and only if. Well, this is an intuitive definition. So this is not necessarily a truly mathematical rigorous definition, but this captures the intuition very precisely. So C is a subtype of P if and only if a value of type C can be safely used or safely replaced wherever P is expected. Well, let me just give you a simple example. So at least intuitively, for example, let's say P is a type representing a general shape. It may be rectangular, ellipses, circles, other polygons. So P is a general shape. And let's say C is a type representing rectangular. So rectangular is a subtype of shape. Well, of course, it actually depends on how you exactly define shapes and rectangular, but just intuitively. So rectangular can be a subtype of shape because, so whenever you expect a general shape or shape of any form, maybe rectangular, circular, circle, a square, there's no problem if it happens to be a rectangular, right? So this kind of relationship is captured by this notion of a subtype. When exactly one type is a subtype of another. So it is, of course, determined by how you define it in the programming language. But this is the intuition behind this notion. And most importantly, when C is a subtype of P, we allow this assignment. So we allow you to assign a variable of type P, a value of type C. So a variable of type P getting the value of type C. So you can intuitively argue why this is safe. So like I said, a value of C can be safely used wherever P is expected, right? So this is the definition, right? And if a variable of type P happens to hold a value of type C, so in other parts of the program, you check the program whether the particular operation is safe or not by the type of P, right? So because on the surface of the program, what you have is a variable of type P, right? So for example, when you apply a method like dot area, you determine whether this is legitimate or not by the type of S, which in this case is P, right? So as long as P is a type that has a method area, then it should be okay, right? And if a value of C can be safely used wherever P is expected, which basically means that C should also have a method area when this value can be assigned to a variable of type P. So this is the basic and very fundamental notion. And many of the programming languages you are learning in this class are supporting this notion of subtyping in one way or another. But yet there are some different approaches to subtyping. Subtyping is a very general notion that appear in many programming languages. And the way it exactly appears in a particular programming language differs from one language to another. So in some languages, these subtype relationships are all about the relationship between classes. So you normally define, for example, a class, let's call it a shape. And later you say, okay, I want to define another class, a rect or a circle or ellipse or whatever, by extending this shape class. And by you are explicitly declaring that rect or circle are derived from this shape class, the programming language understand, okay, so rect is going to be a subtype of shape. So this is one approach. And another type of approach is, so you have another mechanism to define a parent class, something that that looks like P in this definition, like interface. So this shape, something like a shape, is not defined through ordinary class definition. So there is another mechanism, something called interface, or in some other languages like Rust, it is called a trait. Some other languages call it abstract class. So the name differs between languages, but there's another mechanism whose sole purpose is to become a parent type of these actual classes. So these actual classes are often called the concrete classes. So basically, for example, in the previous example, basically you say S has a type shape, whether it is a concrete class or an interface. And you define rect or a circle so that all these data can be safely used wherever a shape is expected. And the other differences between programming languages when it comes to subtyping is how exactly this relationship, subtyping relationship is established. So in technical terms, this is a distinction between something called a nominal subtyping or explicit subtyping versus structural subtyping. So in nominal subtyping, subtyping relationship is admitted only when so declared. For example, only when you explicitly say, okay, I want to derive this rectangle class from shape. In the other approach called structural subtyping. So you don't have to explicitly say, okay, I want to make this rectangle from shape. Well, if they happen to be compatible in some sense, the subtyping relationship is automatically established. For example, when shape says, okay, so all shape classes, all shape types should have area method. And if rectangular class happens to have an area method, then the subtyping relationship is automatically established. This is the structural subtyping approach. So different languages take different approaches. So these are things I want you guys to conceptually learn through the today's exercise. So exercise is all about writing code, but the idea or concepts behind these exercises are what I have explained. So, okay, so it's already time. So let's get started with the exercise. So let's do it until, okay, so we are already, so it's already 11. So let's do it until something like 11:30. So until something around 11:30. So it's 11:25. So let's keep working on the same exercise. But from now, so for those who have already done with the problem, let's share your answer to this spreadsheet. So please write your answer to this spreadsheet, the sheet number 2. Okay, so some of you are already doing. And for those who haven't, and for those who have some sort of struggling, then do not spend too much time trying to solve everything by yourself. Never hesitate to look at others' answers. And let's keep doing it for another 15 minutes until 11:40 or something. And after which, let's move on to the last step, in which you summarize and exchange what you think you have learned. Okay. So let's do it in another 15 minutes. Okay, so let's move on to the next and last step of today, which is to summarize in plain languages or natural languages and exchange what you thought you have learned about the language you chose. So all in all, so what we are trying to accomplish at the end of the day is to be able to write something like this. So here's an array whose some of whose elements are rectangle and others are ellipses. And you have an array who has both rectangles and ellipses. And yet you want to be able to write something like this. So you scan the array, and for each element, you just call area. And an appropriate version of area method gets called depending on what a really is, right? And more important goal is to make it type safe. So while allowing something like this, we like to guarantee that all type errors will get caught before you run the program. But not all languages do that. But so just ask yourself through the experiences you have just had, whether the language you chose guarantees type safety or not. So try to articulate and express in your own terms what is the approach taken by the language you have chosen. So in the last 25 or 30 minutes, so just follow the link of the language you have chosen and start writing your own thought. So for example, in this case, in the case of Julia, so each sheet has 3 questions. So one is very basic. So how you define method in the language you have chosen, and how does the language you chose allow, for example, a single variable to take multiple different types at runtime, values of multiple different types at runtime. And the final question, which is actually most important, is whether the language you have chosen actually tries to guarantee type safety. And if so, how? So think about it for something like 15 minutes or so. And actually, you can see the answers from others by seeing others' posts, right? And you actually you can actually like any post, whichever post you liked, and posts that receives many likes will appear in this popular tab. So after a while, you guys start liking whatever post you like and seeing these popular posts. So which hopefully will elucidate the best thoughts of this class. So in the first 15 minutes or so, just try to your own thoughts. Okay, so it's 11:55. So let's do the last stage of the class. So let's start looking at posts made by others. So just visit any of these. So you can actually visit any of these. So no matter which language you have chosen. So you can see others post by just clicking this others post and press like this heart icon whenever you feel, okay, this is a good summary. So this is a good post. So actually, so you are seeing different posts depending on who you are. So actually, these others posts are randomly shown to each of you, and so do not. So you don't have to find the best post to press a like button. So just skim these all these posts and just press like whenever you feel like, okay, so this is a reasonably good post. So just feel like pressing likes for any number of posts you liked. So the idea is, so nevertheless, posts that are liked by many are likely to be showing up in this popular post. So just start looking at other posts and start pressing like buttons for posts you liked. And after a while, you just start looking at popular posts.
Just in case you haven't clear that. So you can choose different questions for each form from this part. So there are 3 questions in each form. So you can do the most important. I'm just okay.
Okay. So we are gonna finish in a few minutes. And before we end, so we are going to make groups of you guys for the rest of the course. So like I said in the last week, I believe each group will be a group of 4 students. So each working on each language. And to make this grouping, so please go to ITCLMS and take a survey to group students. So basically it's asking your preference for languages and where you are going to take this class, whether you are mainly from home or you are mainly in this classroom. So depending on the properties, I make groups. And I should note in advance that not all of you can work on the language you prefer most. So because of the constraint that each group has one person working on each language. So please have this in mind. And this is due this weekend. So please answer this survey until the end of this week. And the other thing is, so don't forget to write a reflective essay, so which happens every week. So right after each class, but it is due tomorrow. So let's so please get it done until tomorrow. And so I guess many of you are still writing your own thoughts about this and looking at others. So let's keep this happening for a while. So if you have some more thoughts, perhaps during writing this essay, if you come up with some other thoughts, just put it in the this Learn with One site, and also look at others and press like button. So hopefully I will make a brief lecture summarizing what is actually the approach taken by each language. So I'm trying to summarize in my own time. Okay, with that, I think it's time to finish for today. So if you have any question. Okay, so that's it for today. So let's see you next week.